Okay, so practice 9.1. For each of the following settings, define the parameter of interest and write the appropriate null and alternative hypotheses for the test that is described. I don't know why I remember this, but last year a lot of students on the daily tech ended up missing number 1, at least parts of it, because they've asked us to do 3 different things for that question. So what 3 different things do we have to do? Parameter of interest, null hypothesis, alternative hypothesis. Students tended to just do the null and the alternative and not write the parameter of interest at all. You can't do that. We have to define what the parameter of interest is first, okay? So part A, the mean weight of loaves of bread produced at the bakery where you work is supposed to be 1 pound. You are the supervisor of quality control at the bakery, and you are concerned that new personnel are producing loaves that have a mean weight of more than 1 pound. So what kind of symbol should we be defining to be our population parameter? Mu. Okay, so what gave you a hint that it was mu? It says mean, right? Okay, and you're literally, like I've been telling you, going to just plagiarize their sentence. So our population or our parameter of interest is the mean weight of loaves of bread and I want to stop right there, and I would actually be wrong. That's the population we're studying. It's not the population of interest. Okay, of interest, I have to say it's the bread at my work because that's my interest in this problem. Does that make sense? So it's just the population in general, then it's all the bread. But no, it's actually, I need to keep going, and it's at the bakery where I work. Okay, so remember that we are going to start with HO for null, and we're going to start with HA for alternative. We know that the null hypothesis has to have an equal to sign. We've already defined the population parameter, so we have to use mu for both of them. What is the value that the number value that we're going to be using for our hypotheses? 1. Everybody okay with that? It says 1 pound is the, it's supposed to be 1 pound. So both of them are going to have 1. And then what do you think the symbol for our alternative is? Is it going to be less than, greater than, or not equal to? Why do you think it's greater than? Good. Right at the end, you're concerned that they're producing more than 1 pound. So we're concerned that it's greater than 1. Everybody okay with that? Okay, according to the Humane Society, 33% of households in the United States own at least 1 cat. You are interested in determining whether the proportion of households of the students at your school that own at least 1 cat is different from the national proportion. So what symbol are we going to define for our parameter of interest? P. Very good, P. And what is it? It's the proportion of all households where? Yeah, we have to say at our school, unfortunately, because it's the population of interest, not just population. So I really care about the households from my school, not just all U.S. households. Okay, so the proportion of all households of the students at my school that do what? That own at least 1 cat. Are we okay with defining? Okay, so start with the H sub O and the H sub A for the null and the alternative. Again, that's the part a lot of students got lazy about last year and just quit writing, and I don't know why. You've got to put those symbols in to tell me which, and always do the null first, always do the alternative second. Null has to be equal to, we've already defined the variable to be P. So what value are we going to use there? 33%, so we could put 0.33. And what's our sign going to be for the alternative? It's also going to be 0.33, but is it less than, greater than, or not equal to? Does everybody agree with not equal to? You think greater than?
Greater than.
Why are you saying greater than? Because it says at least one. Why are you saying not equal to?
Because it's saying different.
Is different from. That is actually the key. So the at least one is just, you own at least one cat. We don't want to compare it to who owns greater than one cat versus who owns less than one cat. It wasn't set up that way, right? It's just what proportion own cats. We don't really care how many, so we want to know, you know, at least one. Like you own a cat, basically. You can have more than that. We don't really care. But it just says it's different from the national proportion. Y'all get why it's not equal to now? So the at least one is kind of a distractor. The different from is what gives us the symbol that we need. Okay, number 2. Consider the bakery problem in question 1A. Suppose you weigh an SRS, simple random sample, of bread loaves and find that the mean weight is 1.025 pounds, which yields a p-value of 0.086. We're not at the point right now where we could verify that. We will learn in later, 9.2, 9.3, how we would actually use our calculator and find the probability under the curve and all that. We can't do it right now. They don't even give us a standard deviation to work with. So we wouldn't have enough information to find it. So we just have to trust them. P-value is 0.086. But just know that we will get to a point where we have to calculate and find the p-values ourselves, okay? Interpret the p-value in the context of the problem. This is my favorite part, y'all. Yuck. Can we just look at the answer? Are y'all okay with that? Unfortunately, you're going to have to memorize it. It's something about, I'll just look at it with you. Not even going to throw a try out there at you. Let me blow it up for you. So we're on number 2. So here it is. If the true mean weight of bread loaves is 1 pound, the probability of getting a sample mean as large or larger than 1.025 pounds is the p-value. Okay, they're not going to ask us to do it, but let's talk about what the interpretation of the p-value would be for the cat problem. And let me just make up a p-value. You don't have to write it down, but let's just talk through it. If I said that the p-value is 7% for the cat problem, part B, we would say if the true what? If the true proportion of households who own at least one cat is, instead of 1 pound, what would we say? 33%, then the probability of getting a proportion not equal to 33% would be 7%. Did you hear how I changed it instead of larger than? I changed it to not equal to, because that was what our alternative hypothesis was. So this part right here, I'm going to circle it in blue, large or larger than can change. It can be not equal to, like not different from. It can be smaller or smaller than, couldn't it? As small or smaller than, thank you. Do y'all get what I'm saying? Depending on your sign of your alternative hypothesis, the part I circled in blue is going to change based on is it less than, greater than, or not equal to. That's my least favorite part of this worksheet. Back to the worksheet to do it together. Are we okay? So what conclusion would you draw at alpha is 0.05 and then versus at alpha is 0.10? Remember that you're comparing P with alpha. So our P value, they say, is 0.086. How does that compare to 0.05? It's greater than. Good. So we have P greater than alpha. So what conclusion does that lead us to? Very good. We failed to reject. I had a really sweet little girl in stats last year that she said the way she finally just remembered it, because it's hard. You got to figure out a way that's going to work for you. Is she said the one that's greater has more words for the conclusion. The one that's less than has less words. So like P is greater, failed to reject has 3 words. P is less than is only going to have that 1 word of reject. That worked for her to try to memorize which one was which. So P is greater, we fail to reject the null, and then comparing 0.086 to 0.10 instead, what would you say about that? Now it's less than, right? So now we have P less than alpha, so we reject the null instead. Are we okay with all that?
That's a 5.8, right? Or a 0.
It's a 0. It's the p-value that they had given us in number 2. Okay, here we go. A contract between a manufacturer and a consumer of light bulbs specifies that the mean lifetime of the bulbs must be at least 1,000 hours. As part of the quality assurance program, the manufacturer will institute an inspection program for each day's production of 10,000 units. An ordinary testing procedure is difficult since 1,000 hours is over 41 days. Since the lifetime of a bulb decreases as the voltage applied increases, a common procedure is to perform an accelerated lifetime test in which the bulbs are lit using 400 volts compared to the usual 110 volts. At such a voltage, a 1,000-hour light bulb is expected to last only 3 hours. So instead of having to study it for 41 days, they just study it for 3 hours instead. This is a well-known procedure, and both sides have agreed that the results from the accelerated test will be a valid indicator of lifetime of the bulb. The manufacturer will test the hypotheses. The null is mu is equal to 3, and then the alternative is mu is less than 3. At the alpha is 0.01 level, okay, 1%, with an SRS of 100 bulbs. Describe what a type 1 error would be in this context. So let's start with the basics of what you have to memorize. What is a type 1 error? And then we'll put it into the context of the problem. Reject the null. Okay, type 1 is when you reject the null, but the null was true. There was, like, it came out that it was actually true. We rejected it. We said, nope, that's not true, but it was true. So what is that in the context of this problem? It's actually 3 hours. So we say the bulb can't last 3 hours, but it really can last 3 hours. So basically we're saying we're not going to accept these bulbs. They're bad, not working bulbs, but they were good bulbs, right? Y'all get that? So describe it in the context. We would say I'm just scribbling on the board now. Okay. We say the bulbs don't last 3 hours, but they really do. I know that's a very simple way of saying it. I'm sure the answer's sheet, you know, answer key says something much more, I don't know, higher level, but that'll work for us, okay? What is the probability of making a type 1 error when performing this test? Give me a number. 0.01. The probability of making a type 1 error is 0.01. Okay, it's the alpha. Probability of making type 1 is alpha. It's 0.01. Describe what a type 2 error would be in this context. So back to just the reject, auto reject, all that, what is a type 2 error? Accepting the null when it's actually false. Okay, so you're failing to reject the null, but it was that the alternative was the good part, like the null was the bad part. So that was when the HA was true, I think is what our notes said, our PowerPoint said. But it says it's in the context of the problem. So we say that the bulbs do work when they really can't last the 3 hours. Does that make sense? We say the bulbs do work but they really can't last the 3 hours. I'm putting don't. They really don't last 3 hours. Got to erase it, unfortunately, to get to D. Are we all okay with all that? Are both errors bad for the company? What's bad about type 1? So they made all these bulbs, this company, and they're like, hey, this batch of bulbs doesn't last 3 hours. Let's throw them away and not use them. They lost money, right? Because they could have put them on the market and made money off of them, and those bulbs were fine. Okay, what's going on in the type 2? They're putting out faulty bulbs. So they're touching the bulbs. They're like, oh, these are great. Put them out there on the market. The customer's getting them. They're not lasting 3 hours. So it's actually kind of good in the beginning for the company because your bulb doesn't last you as long, so you go buy more bulbs. But then isn't the consumer going to be mad? Because the bulbs don't last 1,000 hours that the company is putting on the box that they say they last. Okay, so then that answers our part D for us. Which error, type 1 or type 2, is likely to do more damage to the manufacturers, not money, but their relationship with the consumer? That's going to be type 2 because you're basically lying to your consumers. Type 2 because you're giving them bad bulbs.